Good morning everyone. So in our previous lecture, we have seen about the Ohm's law, in which some of the questions can be asked you according to the marks. Like for 2 marks, they can ask you a circuit diagram. For 2 marks, they can ask you a law, Ohm's law, and the conclusion of it. And for the 3 marks, they give a question like you have to write a whole practical of Ohm's law. And from there, we get an equation. That equation is V is equal to IR. IR. Where the V stands for potential difference. It's a potential difference. While the I stands for electric current and the R is for resistance. So that's the most important equation for us, because after this a whole chapter holds by this equation. In every theory you can see that equation for finding any other equations or relate to the other things. Generally after this one, after the Ohm's law, whole chapter working on this law, and in each and every point of it there is a Ohm's law stands and give a appropriate presence of it. So it is the most IMP important equation for you, which is the V is equal to IR, right? For easy understanding or for easily remembering, I am just saying it IR, that the V is equal to IR, which is the equation for the Ohm's law, right? Now, with the help of it, there is some of the examples which are given to you in your book, like example 12.3. In your exercise, there is one question, example 12.3. What is the question? The question is that how much current will flow on electric bulb drawn from the 220 volt source and 200 ohm? How much current will an electric bulb draw from 220 volt source and the 1200 ohm? So in this one, example 12.3, the voltage is given to you, which is 220 volt, and the R is given to you, which is 1200 ohm. Here is the voltage 220 volt and the resistance the 1200 ohm, and you have to find out the current drawn by the filament of electric bulb. The easy one is that V is equal to IR. The I is equal to that you have to find. The V is given to you, which is 220, and the R is 1200. Now take this 1200 to another side. That gives you 220 divided by 1200 is equal to I. Both the zeros are cancelled out. 11 twos are 22 and 60 twos are 120. So the I is 11 by 60 ampere. If you want to find out in a point, and you can also find like 11 divided by 6. 6 ones are 6, then 5. So it's a 50. There is a point. 6 8s are 48. And 20. 6 3s are 18. 20. 6 3s are 6 3s are, so like that. You get 1.8333 up to dot 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 divided by 10 ampere. I am just taking 6 ampere. So the I is equal to 0.18 ampere. 0.18 ampere. Or you can write this answer, then it can be also appropriate for you. Right? You can do it at here also. You can take this answer also. So the I is 0.18 ampere, which is drawn by the filament of a bulb at a 220 volt of source and a 1200 ohm, right? So here it is the electric current which is drawn by the electric bulb, whose the resistance is 1200 ohm and which is connected with the 220 volt, which is easily answered by us with the help of V is equal to E. So here is the example number 12.3. If you want to see it, just see it for some time, like 2 to 3 seconds. It's not that much bigger that it takes more time for it, right? So I think you have seen it. Okay. So now the another question. In this question, example 12.3, there is a two different points at it. One is a and another one is a B. That you have to also find. What is the B? According to B, how much current will an electric heater coil draw from a 220 volt source 100 ohm? Now there is an electric heater in which the voltage is same, which is 220 volt, but the resistance is less, which is 100 ohm. And as you know that as the resistance decreases, the current is increases. We are using the same equation. V is equal to I. Now put the value. V is 220 volt. I that you have to find, and the R is 100. So 220 divided by 100 is equal to R. These zeros are cancelled out. So the answer is 2.2 ampere. So I is equal to 2.2 ampere. So heater draws 2.2 ampere while the bulb draws 0.18 ampere. If it is connected with a 220 volt, the internal resistance are also given to you. For the bulb it is 1200 and for the heater it is 100. So like that you can use a Ohm's law to find the current. How much current is flowing from the apparatus, like in our home. There is generally 220 to 230 volt is given to your home. So the source is 220. And now, if you are thinking about how much current is drawn from the television, then you need to find what is the resistance, which is generally given in the manual of it. And then you can easily find out what is the current. Just like that, our charger has also some of the indicators are there. Like a 230 volt becomes a 5 volt, and the current becomes a less also. Like that, the V is Ohm's law is 1, and you can easily find out the I. Understand? Now, there is one other question. Example 12.4. It's not a problem, okay? Example 12.4. Now, what is the question? The question is that the potential difference between the terminals of an electric heater is 60 volt. When it draws a current of 4 ampere from the source, what current will the heater draws? Of 120 volt. Okay. There is one heater is connected with a 60 volt. So the V is 60 volt. During that time, the current is 4 ampere. Now they are saying that if it is connected with the 120 volt, then what will be the current? As I said you in Ohm's law, that the resistance is depend on the material, and the heater is same, so resistance will be the same because we have connected the heater to the 60 volt. The same heater is connected with the 120 volt. Understand? So you can easily find out the resistance, and this resistance is same for both of the things, for both of the voltage. If we are taking here V1, then the I1, V2, then I2, but R is same for both. The R is same. The R never change because it is a constant for any materials for a constant temperature. So we can find out the R with the help of it. Then you can easily calculate the I2. So at here we are using a Ohm's law. So according to Ohm's law, what you can use? You can use an equation. V is equal to IR. But at where? There is a two different voltage and the current we are taking. V1 is equal to IR1 R. So at here you have wants to find the R. So take this I1 in the other side. Then it becomes V1 by I1 is equal to R. So the R is equal to V1 by I1. Now the V1 is 60 volt and the I1 is 4. So what is the answer of R? So it's 4 ones are 4. So it's a 15 ohm. The R is 15 ohm. Oh, it's simple. I'm just 15 4 is 60. So it's a 15 ohm. Now put this value at here because the resistance are same. Now using the same law, Ohm's law. So it's a V2 is equal to I2R. You have to find out I2. Take this R into another side. Then V2 by R is equal to I2. So the I2 is equal to V2 by I. What is the value of V2? It's a 120, while here it is a 15. 15 is a 120, so it's a 8. Understand? So when the 60 watt, the 4 ampere is closed. When the 120 watt, it's 8 ampere is full, which we have found. If you want to do this method, then you can use it, or you can use another method. Like as we know that according to Ohm's law, V is directly proportional to I. So we can say that the V1 is directly proportional to I1 and the V2 is directly proportional to I2. If we take the ratio of both of them, then the V1 by V2 is equal to I1 by I2. Because in both the case, if we are taking the R at here, like V1 is equal to I1 proportional to I1, so V1 is equal to I1R. Like that the V2 is equal to I2R. Now put the value at here RR, both the RR cancel. So at here V1 by V2 is equal to I1 by I2. Now you have to find out the I2, then take it in the other side. All things should be there. So the I2 is equal to just I2 at here, so I1 is at here, V2 and the V1. Take this V2 in this one side, then it is denominator, it becomes numerator. Now put the value, I2 is 4, it's a 120 divided by 60. 62 is a 120, so it gives you a direct 8 ampere. So you can use this method also. At here you are using to find the R. Sometimes they ask you for finding R. Sometimes the questions can be like that. The potential difference between the terminal of an electric heater is 60 watt when it draws a current of 4 ampere from the source. What current will the heater draw when it is connected with a 120 watt? Find the resistance of heater. Then you have to find it. But if the question is not like that, just they are asking for current, then you can use this method also. Because 15 ohm is common in both the sides, so they both will cancel out. And you can easily find out the I2 with the second method. It can be easy for you, like yes, I know that at here you are just little bit confused because of the lack of space, but I will show you again. Or right, I will show you again. At here, according to Ohm's law, we can say that the V is proportional to I. So like that, V1 is proportional to I1. So V1 is equal to I1R. If the V1 is equal to I1R, then if we are taking V2, then I2 will change, not R will be changed. Because V2 is also proportional to I2. Now take the ratio of both of them. Then what will you get? V1 by V2 is equal to I1R by I2R, where the both R are cancelled. So what you get? You get V1 by V2 is equal to I1 by I2. Now you need I2 in this side. So put it in this side. Here it is a denominator. As it goes in a other side, it becomes numerator. So V1 I2 by V2 is equal to I1. But we need only I2 at here because we want to find out. So all things should be there. Then the I2 at here I2. V2 will at here and V1 at here. Put the value 4, 120 and the 60. So it gives you 8. Due to a less space, I can't make you understand like that. So I have to just show you again. Understand? So like that you can easily explain that how the current becomes double as you double the voltage. So as you increase the voltage, current increases in the same manner. Proportional. Both are proportional to each other. So as the voltage increases in the same amount or in the same manner, the current will also increases, right, in a proportion. So here is the example of it. There is one another example which is given to you, which is from the example 12.6 or something other one. Okay, that the question is that if the voltage potential difference given to the any material becomes a half, then what will occurs with the current? What will be the current? If the voltage becomes half, as at here you can see that as voltage becomes double, the current will also becomes double. Like that, if the voltage becomes half, the current will also becomes half. That I am also showing you. Like if you are thinking that the one object is with a voltage V. If you are thinking that one of as a V1 as a V voltage, and for that the I1 as a I. Now when we have the one, okay, first of all I am just going with it. Then you can say that according to Ohm's law, V1 is equal to I1R, which is the equation number 1. Okay? Now, put the value of it. Then V is equal to I. Okay? So here it is the equation number 1. Now half the voltage. Half the voltage. If new voltage becomes V2, then the V2 is equal to V by 2. As the V2 change, I2 will also change. Then what will be the I2? Then according to it, you can say that the V2 is equal to I2R. V2 is equal to I2R. But the V2 is a V by 2 is equal to I2R. What is the value of V? V is equal to IR. So it's a I by 2 is equal to I2R. From both the sides, R is cancelled out. So you can say that the I by 2 is equal to I2. So the I2 is equal to I by 2. So as voltage becomes half, current will also becomes half according to this. So here it is the Ohm's law that you can use for so many electric circuits. Like how much electric current you need, according to it you can give a potential difference. You can use a resistance according to it. Sometimes we need a more current, then we can decrease a resistance of it. Give some more voltage and you get a more current. But sometimes we need a small amount of current, like in our chargers, in our mobiles. As you know that a refrigerator, AC needs a more current, a more voltage. Mainly the voltage is same because it is given by the GB, which is a 230 watt, which can't be changed. So according to it, what we can say, what we will do, we just decreases a resistance, and according to it, the current, more current can be flow from it. While for a small apparatus, we need a small amount of current. So everything is depends on this Ohm's law, which is the heart of finding most of the circuit. Understand? So here it is the Ohm's law, and some of the sums related to Ohm's law. So we just finished our topic at here. The another topics which is just a little bit different from it. It is the heart of it. So I have just taught you before the Diwali, right? That you can easily understand it, or you get a more time to give this topic. So you can easily or conveniently give proper focus in the remaining topics. So we can see the another remaining topics after Diwali. I will send you Diwali homework in a PDF. Thank you.